Algebra 1 students, welcome to your 3.6 notes, Compound Inequalities. This is a great section of math, but it's also a great song to lead into it. I hope you're enjoying this jam. Now, let's go ahead and do some learning. So compound inequalities. I'm going to show you two methods to solve compound inequalities like the ones you see here, number 1 and 2. The first one is the method that will work all the time. And what we're going to do is actually break this compound inequality apart. So we're going to say negative 10 is less than y plus 2. And whenever you see the compound inequality written like this, there's an implied word and, it's in between them. So and y plus 2 is less than negative 4. So what I'll do is go ahead and subtract 2 from each side, and I'll have negative 12 less than y, and subtract 2, y is less than negative 6. Now when we have these and compound inequalities, we want to put them together to look something like this: negative 12 less than y less than negative 6. It's essentially two problems for the price of one. Alright, now I'm going to show you an alternate method here. This won't work all the time, but when it does work, it can be kind of nice. We're basically going to treat this next problem as if we have a three-part equation, or in this case inequality, and so we're going to do everything on all three sides of the equation, if that makes any sense. So I'm going to multiply everything by 4 to start with. It's kind of weird to show this in the middle one, there's not a lot of space, but when you multiply by 4, we'll have negative 12 less than or equal to, now remember this 4 will cancel this 4, so we'll have 11 plus x, which is less than 12. And then, as you know, if you have 11 plus x, you would need to subtract 11. So normally we say we'll just subtract it from both sides. In this case, we're going to say from all three sides. So negative 23 is less than or equal to x, which is less than 1. Now, go ahead and give it a shot on your own on number 3. I have to caution you, though, the second method I've shown you will be problematic here. So we're going to use the first method. Break it apart and solve. Alright, welcome back. You could see my work. Let me walk you through it a little bit. I basically just split this inequality into two distinct inequalities with the word and in between them. First one, 4 is less than y plus 2. And the second, y plus 2 is less than or equal to, and I went ahead and distributed the negative 3, so negative 3y plus 18. And then you can see the process. I went through and solved both of these for y. You can follow my work on that. And I got 2 less than or equal to y and y less than or equal to 4. And then I combined them into the one solution you see here, 2 less than or equal to y less than or equal to 4. A little tricky, but you can handle it. Alright, let's take a look at the next situation here. We're solving inequalities and graphing solutions. Now this is still a compound inequality on both 4 and 5, but notice that the word has changed. It's or. Alright, so let's take a look at this one. First thing I'm going to do is subtract 5 from each side. I'm just going to solve these as two separate problems essentially. So negative 5 is less than, or excuse me, negative m is less than negative 1. And then you need to divide each side by negative 1 so we can get rid of that pesky negative sign. And we'd have m is greater than 1. The other inequality is a little bit faster to solve. Just divide by 7. And we get m is greater than 5. Now remember, the word here is or. Alright, so what I'm going to do is actually just pick a spot on this graph to decide. That will be 0 right there. And that means this right here would be 1, 2, 3, 4, 5. Again, I'm not so worried about everything being to scale as I am just make sure you label points. M is greater than 1. Or m is greater than 5. What that means is, for this statement to be true, only one of those two things has to be true. But the weird thing about this particular case is that both are actually going to the right. Now, We did have an open circle at 5 because it says m is greater than 5. However, I'm going to go ahead and get rid of that open circle because it's included in the other part of the inequality of m being greater than 1. So your graph should look something like that. Alright, I don't really like that we started with that one. I would have preferred to start with this, but it was the order it was in, so I'm going to roll with it. On the next one, on number 5, we're going to subtract 3 from each side, and then of course divide by 3. So x is less than or equal to negative 4/3. In this case, we'll subtract 2. I know I'm skipping showing some steps. I'm verbalizing it. Hopefully it's working for you. Ask questions in class if you have questions about it though. 5x equals 10. We would divide by 5. I know this is an inequality, so we treat it the same. We divide, and again, because we're dividing by a positive, we don't have to worry about any changes of sign. Okay, so there is the inequality. Now remember, I've got a missing word here. Need to include it. Or, and let's go ahead and graph this thing. I'm going to say that this right here is 0. That would mean right here is 2. And negative 4/3 is like 1 1/3. So I'm just going to say about here, that's negative 4/3. And let's go ahead and graph this thing. It says x is less than negative 4/3. That's a closed circle. Less than equal to, I should say. I read it without saying it out loud. X is greater than or equal to 2. Again, a closed circle. This time the arrow goes right. This is the more traditional or inequality situation, compound inequality, when you get two graphs, two rays going opposite directions with just a gap in the middle. Alright, let's take a look at the next one. Write a compound inequality that represents each phrase, and then we'll graph the solutions. A real number that is less than 4 and greater than or equal to 7. Okay, I'm just going to put this out there right now. This statement makes no sense. So something has to change. Here's what's going to change. In this case, I'm going to change that word and to the word or. Apologies for that. All real numbers that are less than 4 or greater than or equal to 7. So all real numbers less than 4 would look like this. X is less than 4 or greater than or equal to 7. So x greater than or equal to 7. That's what the inequality would look like. Let's go ahead and graph this thing. So I'm going to decide that this is 4, and right here that's going to be 7. And at 4 we should have an open circle. That's a pretty large open circle there, trying to make the point. And at 7 should be a closed circle, and the graph would go to the right. Alright, let's take a look at the next one. So here we have the area of a standard fish tank is between 3 square feet and 5 square feet inclusive. Let's talk about that word for a minute. Inclusive means including the end or ends. In this case, that would be both cases. So 3 and 5 are part of the situation. Here's the way I would write it. I would write it as a compound inequality. 3 is less than or equal to x, which is less than or equal to 5. So I'm going to decide right there that that's 3, and that's going to make that 5. Why not? Close circles on both and connect. That's it, right there. Kind of a strange situation on that one, I have to admit. But it's better than having the wrong word on number 6.